Hello everyone, so this is our Encryption 101 KMS video, and in this video we will see the overview of encryption mechanism and we will see how we can work on it. Okay, so let's start. Why encryption? So why encryption is necessary? So first, an overview of encryption mechanism, and the first one is going to be encryption in flights. Then why would we want even encryption in flights? Well, we want encryption in flights because if I send a very sensitive secret data, for example, my credit card to a server to make a payment online, I want to make sure that no one else on the way can see my credit card number, and that is very necessary. So I want to make sure that when I make a payment online, I have that green lock. I have that HTTPS website which guarantees me that it is an SSL enabled website and I will get encryption in flight. So when you have encryption in flight, the data will be encrypted before I send it and the server will be decrypting it after I receive it. See, here it is written. But only myself and the server knows how to do these things. Now the SSL certificates are what is going to help with the encryption, and so another way to see it is HTTPS. So anytime when we have been dealing with the Amazon service, it had an HTTPS endpoint that guaranteed us that it was encryption in flight. And now the whole web, almost the whole web, need to run on SSL and HTTPS. So you are protected against the man in the middle attack. That means anyone who can intrude you or intrude your privacy. So encryption in flight ensures you that no one is intruding, no one is looking into your data, and no one is just stealing your data. Okay, and so this guarantees that when you have that green lock and that the server web certificate is valid, that no one can retrieve your sensitive information. Okay, so let's do a quick example here. Suppose here is your sender. It could be anyone, an HTTP website on AWS, could be DynamoDB, could be whatever we want. And then we are going to do is what we are going to have, add the super secret data. We are going to encrypt it with SSL encryption and send it over the network. Then the website will receive the data and know how to decrypt it. Very, very simple, the idea of it, but the execution is not as easy. So this is how much I'll give you. The good news is that all programming languages know how to do SSL encryption and decryption and already do this for you. So you don't have to worry about anything. This is not something you have to deal with directly. And the second thing is going to be called server-side encryption at rest. And so that is when the data is encrypted after being received by the server. So before that, the server was receiving data, decrypting it and using it in its decrypted form. Okay. Here the server is going to store the data on its disk, and so we need to know that the server is storing the data in an encrypted form, because in case the server gets hijacked by someone else, we don't want that someone else to be able to decrypt the data, and so the data will be decrypted before being sent back to our client. So thanks to a key usually called a data key. Okay, this is a data key which stores the encrypted form. Okay. And the encryption and decryption key must be managed somewhere, usually called a KMS. And this is what we are studying. This is we are looking into it. This is Key Management Service, and the server must have the right to talk to the Key Management Service. So here is our object, and we are going to transfer it, for example, to EBS. So it's going to be transferred over whatever mechanism, and EBS will use a data key, and using a data key will perform encryption of that data, and now it's stored in an encrypted form. And then the day we need to retrieve this for whatever the reason is, then EBS, the AWS service, will do decryption for us using the data key again. Okay, and we'll get that decrypted data. And back to us over at HTTP or HTTPS. For example, this is how server side encryption works. Okay. And as you can see, server side itself of the services manages the encryption and the decryption and uses a data key it has to access. So this is for server side encryption at rest, but we have seen that many AWS services do use that encryption at rest. Now let's talk about client side encryption. This is client side encryption. In client side encryption, the data will be encrypted by the client, and the client is us. Basically, they are us. Data is encrypted by the client and never decrypted by the server in between. It is decrypted by the client only, the client who is receiving the message, who is receiving the data. Okay, So all in all, the data is just stored on server, but the server does not know what the data means, what is stored in the data, but the server doesn't know what the data means, and the server, as the best practice, should never be able to decrypt the data anyway. And for this, we could be leverage something called envelope encryption, but I have a whole lecture on this later on because this is pretty advanced, but the example asks you about envelope encryption. So for now, let's do an abstraction for it. So we have our object and our client. We are going to use a data key and we are going to encrypt our data client side. So we perform encryption with that data key. Now we send that data to any store of data we want. Could be FTP, could be S3 bucket, anything. Could be whatever you want really. You put your data wherever you want, say Amazon or somewhere else, and then when you receive it, your client will receive an encrypted object, and if it has access to the data key, if it can manage to retrieve the data key from somewhere, then it will be able to perform a decryption and get the decrypted object as a result. So as you can see now, the encryption happens client side. The server data store does not know to decrypt or encrypt data. It just receives encrypted data, and so that is quite secure as well. So here are the three kinds of encryption. You can get overall except envelope encryption, and that will show you later on. So this is not just using any KMS just yet. This is just an abstraction of how encryption works. Okay, but hopefully that clears up what encryption is. And in the next lecture, we are going to do a deep dive into KMS. Now let's talk about AWS KMS, which is Key Management Service, which is the key management service of AWS. We have been using it, a lot without knowing. It is most likely going to be KMS encryption. This aim is that with this KMS service, AWS is going to manage the encryption keys for us, and that is great because that means that we have less things to do. So KMS is of course fully integrated with IAM for authorized, and it gives us very easy ways to control access to our data if it is encrypted with KMS. The power of using AWS KMS is that you are able to audit every single API call made to use your keys through CloudTrail, which is something the exam may test you on. So on top of it, KMS can be used seamlessly in most of AWS services. So for example, if you wanted to encrypt the data at rest in an EBS volume, just enable the KMS integration. Same for S3, same for RDS, same for SSM. For pretty much all the services that required encryption. The idea is that with KMS you can also use it yourself, and if you have data secrets, or if you never ever store them in plain text, that means just as is, especially in your code. So if you want to use KMS, you can also use KMS through API calls. You can use the AWS CLI or the SDK, and that means what you can encrypt is a secret for you with the KMS keys. And then let's see KMS keys. So let us talk about keys types. So we have two types of KMS keys. KMS keys is the new name of KMS customer master keys. It is symmetric AES 256 keys, single encryption key that is used to encrypt and decrypt. And so any service of AWS that is integrated with KMS will use symmetric keys. The idea is that when we create or use a KMS symmetric key, then we never get access to the key itself. All we do is that we use the KMS API calls to leverage and use that key. The second kind of key available on KMS are called asymmetric key, RSA, and ECC key pairs. You have a public key that is used to encrypt data and private key used to decrypt data. So this is used when you have encrypt and decrypt or sign or verify type of operations, and in that case you can download the public key out of KMS, but you cannot access the private key. you can only use API calls again to access the private key. So the use cases for an asymmetric key type of key is when you want the encryption to be done outside of your AWS cloud by user who cannot or don't have access to the KMS API key, in which case they will use the public key to encrypt the data, send it over to you. Within your account, you will use the private key of AWS to decrypt the data. So within the world of KMS keys, you have different types of KMS key. The first ones are AWS owned keys. Okay. These are basically free. SSE, S3, SSE, SQS, SSE, DDB. They are basically default keys. Or you can call them, they are free, and this is the kind of key you would use when you use SSE, S3 type of encryption, or SSE, DDB. DDB, that means DynamoDB. So these are not really KMS because you don't really see them, but they are types of encryption keys within AWS. Then you have the AWS managed keys, and they are free, and you will recognize them because they start with AWS slash and then service name. Okay, example AWS slash RDS or AWS slash EBS, or in this example AWS slash DDB, which is DynamoDB. They are free and you can just use them as you please, but only from within the service that is assigned to. Then you have your own customer managed keys, and they are charged, they are customer keys, and they cost you $1 per month. And if you want to import them as well, you can import them, and they cost you $1 per month. KMS also has a pricing where you are going to pay for each API call made into the KMS service, which is about 3% of 10,000 API calls. You have automation, or you can say automatic key rotation also. So if it is an AWS managed KMS key, then it is automatic every 1 year. Customer managed KMS key must be enabled automatically after every 1 year. Okay. Then you can manually rotate it, and for this you need to leverage an alias. So KMS key are scoped per region. That means that if we have an EBS volume encrypted with KMS key in a region, for example, West to EU West 2, then if you want to copy that to a different region, we have to do several steps. First of all, we have to take a snapshot of this EBS volume. And if we take a snapshot from an encrypted snapshot, then this snapshot itself will also be encrypted with the same KMS key. Then to copy the snapshot to another region, we need to re-encrypt the snapshot using a different KMS key, and this is something AWS will do for you. But the same key cannot live in two regions, so now we have an EBS snapshot. Okay, it's encrypted with KMS with a different key, and it lives in another region. Now we restore the snapshot into its own EBS volume, and it lives in another region. Now we restore the snapshot on its own EBS volume with KMS and its KMS key B into the region AP Southeast 2. Now the other thing we need to know is KMS key policies. Control access to KMS keys similar to S3 bucket policies, with the difference that if you don't have a KMS key policy on your KMS key, then no one can access it. So in that regard, we have two types of KMS key policies. We have the default one, and it is created if you don't provide a specific custom KMS key policy. And the idea is that the default allows everyone in your account to access this key. That means if you have an IAM policy allowing a user or role to access this key policy, you are good. But if you wanted to have one more specific controls over it, you could use a KMS key policy that is custom, in which you define the user, the roles that access your KMS key, and you define who can administer the key. And this is especially helpful if you want to do cross-account access for your KMS key, because we can authorize another account to use our KMS key. So when do we use this? Well, for example, if we wanted to copy an encrypted snapshot across accounts, okay, so we create a snapshot encrypted with our own KMS key, and it is a customer managed key. It must be that because we need to attach a custom key policy, and then we attach a KMS key policy to authorize for cross-account access. It looks like this. Then we share that encrypted snapshot with the target accounts, and then in target account we create a copy of the snapshot, we encrypt it with a different customer managed key in that target account, and then we can create a volume from the snapshot in the target account, and we are done. So that is a lot of information by KMS, but let's go into hands-on. We will do some hands-on after our next video. So let's move on to the next part, and then we will see some hands-on part. Let's learn a bit more about it. So this is your KMS key policy. Okay, so now let's talk about KMS multi-region keys. So we have KMS, and we can actually have a multi-region key. That means that you are going to have your primary key in one selected region, such as, for example, US East 1, and then key is going to be replicated. Okay, this is US East 1, US East and Virginia, and it is being replicated in EU West 1, US West 2, AP Southeast 2, and so the similarity is that key material is going to be replicated. The same key is going to be in the other regions, and the key ID is going to be exact same. You can see the key ID here, and key ID is same 1111112222, and all these key IDs are very much similar to each other. Okay, so what would you use them, and why will you use them? Well, it is a set of KMS keys that you can use in different AWS region, and they can be used interchangeably. So that means if you can encrypt in one region, then decrypt in another region, and multi-region keys, they are possible because they have the same key ID, the same key material, and if you have automatic rotation enabled for the primary key and it actually rotates, it is going to also be replicated to the other regions. So the idea with that, with the multi-region key, you can encrypt in one region and decrypt in another region, and you don't need therefore to re-encrypt your data when moving from one region to next, or to make across region API calls. Okay, you have your primary and your replicas, and each multi-region key is going to be managed independently with its own key policy and so on. So it's not recommended to use multi-region key except in very specific use case, because KMS likes to have the fact that a key is bounded to a single region. Okay, so the use case for using multi-region keys, if you want to have a global client-side encryption on global DynamoDB or on global Aurora, and we will see this in a second. So how does it work when you use global tables in DynamoDB and KMS multi-region with client-side encryption? So the idea is what you want to encrypt, not just the whole table, because this is just at-risk encryption. You want to encrypt actual attributes on your table so that they are only available to specific clients, not even to database administrators. For this, we are going to use this Amazon DynamoDB encryption clients. So let's take an example where we'll have US East 1 and AP Southeast 2. So the KMS service is having a multi-region key which is replicated to another region, the region AP Southeast 2, and the client application wants to insert data into a DynamoDB table. So first is going to encrypt the attribute that needs to be encrypted with a primary multi-region key. So the idea is that the DynamoDB table, most of the fields will not be encrypted client side, okay? But then one of them, for example, the social security number is going to be encrypted. So this is great because, well, your database administrators that have accessed your DynamoDB table, if they don't have access to the KMS key that we use to encrypt that one attribute, the social security number or SSN you can say, then they will not be able to access it. So it gives you a protection even against the database administrator. So if this DynamoDB table happens to be a global table, we can encrypt specific attributes client side in our Aurora tables using Amazon. Okay, wait, this is not Aurora, we were at global tables. Okay, and so if this DynamoDB table happens to be a global table, then this data is going to be replicated to another region, and so this is now in AP Southeast 2, and thankfully we have decided to encrypt our data, and therefore a client's application in the AP Southeast 2 region can retrieve the row, see that one attribute is encrypted, and then perform an API call to actually decrypt the attribute with the replica multi-region key. And this is why we are doing multi-region key this instance. So using this client-side encryption technique, we can protect specific fields or attributes on our data and only guarantee decryption when our client has access to an API key. And thanks to global tables for this. So the same concept can be applied to global Aurora too. So let's move a little bit faster, and this time we are going to use the AWS Encryption SDK. So we have two regions and we have multi-region key. Suppose we have two regions and we have a multi-region key in KMS replicated across these two regions. So the client application wants to encrypt a column yet to get in my SSN column, and this time we put the data into an Amazon Aurora database with a table. And so all the data is unencrypted on this one row except that one column, which is the SSN, which is encrypted. Actually with the MRK, which is multi-region key, now this is a global database, so that means that table are going to be replicated globally. So that means that the tables are going to be replicated globally, and therefore the same data is going to happen to be in this AP Southeast 2, and because we have clients in the AP Southeast 2, they are going to get this encrypted data from a table, and because we are using a multi-region key, they can do a local API call to KMS to decrypt this attribute, and therefore we have achieved lower latency. So we have seen that using client-side encryption, we can also protect this data even from database administrators. So if you have a database admin that accesses your Amazon Aurora database and wants to access that one column, the social security number, unless they have access to the KMS key, they will not be able to read this data, which is very helpful. So that is it for KMS multi-region key. I hope you liked it. So let us do some hands-on on our KMS. So let's start. I'll make one key. I'll show you how we can make one key. Okay, so let's start hands-on on this. So in this part, we will see key management services, which is KMS. And I'll tell you that AWS managed keys, customer managed keys, here are customer managed keys, AWS cloud HSM key stores, and external key stores. Okay, so AWS managed keys are basically managed keys which are actually managed by AWS, and let us see the key policy. Version is 2012 1017. Okay, ID is Auto Elastic File System 1. KMS encrypt, decrypt, re-encrypt, generate data key, create grant, describe key. This is its via service, and via service is basically elastic file system dot, and here is region Amazon AWS.com. Okay, so this is basically an IAM file. Here customer managed keys are basically keys which are managed by the customers, which we will be generating or creating a key. External key store, if you want to import a key store, you can do this, create any external key store, but that is not our part. So we will just see the customer managed keys right now. See, it would charge you like $1 per month, as I said. So if you want, then only you can create a key. Here asymmetric and symmetric keys, as we already discussed about key types, so I have to choose symmetric and encrypt decrypt only. Then I can go for advanced options. So this is KMS recommended, so I'll go with the recommended one. If you want a multi-region key, you can change the regionality from here. I want to do it by default. Next is alias. We can have any name for our key. Okay, so suppose I want to demo, spaces are not allowed. You can describe this key that it is a demo key. Okay, so we have described it here. Then you can add any tag if you want, and then the next level is define key administrative permission. So basically if you don't define any key administrative permission, it will go by default, and here you can define any type of like administrative permission, like execution service role, SageMaker execution, SageMaker service catalog, whatever you want. So you can specify anything from here, but I don't want to select anything. And next is key usage permission. It is also the same thing, and you can also do the next If you want to add any another thing, then you can do this. Like you can add another AWS account, but if you want to go with this account only, and here I can also select I am the users and role that can use the KMS key in cryptographic operation. Suppose if I support suppose I click this, then I'll be accessing, or this Amazon SageMaker execution, whatever it is, it will be basically using my key. Okay, and I am allowing, basically I am allowing this to access my key. And next is review part. Here is the review part. You cannot change the key configuration after the key is created. So if you want to change anything, you can change it here by clicking this previous and moving on to another things. This is your key policy, which we saw in AWS managed key also. So this is our key policy, key console policy, enable IAM user permission, effect allow AWS AR and AWS, and here is resource. Okay, so this is basically our key policy, and I can finish it. Okay, if you want to edit the text, you can also edit the text from here. If you want to allow some, suppose if you are having this one, okay, if you are defining permission here, so you can see action, you got some action, grant, revoke, because I just gave this user the permission to access or use the KMS key in cryptographic operation, and that is why now this key policy is this much longer. Okay, and next, if you will click finish, a key will be created. So right now I don't want to create any keys here, but if you will click finish, then it will be created. See, and then you can use it wherever you want to encrypt or decrypt your data. So this is what demo was to creating a key in AWS KMS console, and then you can use this. You can also view this key. Suppose here is our key, here is the key policy. You can switch to key policy view, and here is the key policy. You can switch to default views in this. Okay, I haven't allowed any key deletion or administrator to delete this key basically. Okay, so this is what how we can create a customer managed key in our KMS. Okay, so I hope this video was very much clear to you. I hope now you can easily access this KMS, and you basically know what KMS is and KMS types, and you can work on this. So thank you, and let's meet in our next video.